When do we want True RMS? I didn't even know you could get a meter at this price point with True RMS. See how it's 120 right on the money, and this one says 117 to 118? Your circuit doesn't have to be loaded. It can be loaded. Voltage just has to be present, and you just make a measurement in parallel, just like that, just across your terminals, across your red, black, or your hot and your neutral. Perm, fan, and C. C is for common, not for cookie. When we turn on an electrical load, our current is going to spike initially. Yeah, it does. Okay. This is a cool trick. I don't know if they'll teach you this in school. For the non-contact voltage setting on these. Hey folks, welcome back to the show. For those of you that are new, my name, we're not even sure at this moment, but you can always check the title of the channel and maybe that'll be a clue. Anyways, today we're going to be going over all of the different test settings on your AstroAI DM103B Bravo, and it's advertised as a True RMS digital multimeter. I've been getting a lot of feedback in the comment section of people asking and requesting, hey, I need help with my meter because I keep trying to test things and I'm shorting things out. And folks, that's exactly what these videos are to help you do. Why don't you grab a snack, have a seat, and let's take a nice deep dive into this AstroAI and help set you up for some success with your electrical troubleshooting. So let's go. Full discrepancy, I'm a huge fanboy of AstroAI, so I will probably be biased. They're not an affiliate, although I really wish that they were. I think they're just a great company. They make good stuff at a good price. And when meter companies like this offer a lot of features at a really good price, it helps grow our community. And I really like that. So just moving forward through this video, just understand that that's the lens that I view this company and probably this product. Let's start with the first, and that is packaging. Notice that this box is just that. It's just a cardboard box. So all the packaging is recyclable right out of the gate. All the stuff that I get from the big box stores is in a bunch of plastic. Now there is still plastic here, obviously. Ooh, we get clips in there. I love that. But this is a pretty small amount of plastic relative to like getting an electronics product. Let's take a look at your leads. The leads are a little bit low end, but this is a pretty low end meter price wise. These aren't great. I would get another set of leads. The thing that I do like that they include is these Alligator clip styles that they essentially slip on are incredibly useful. And once you start using them, you're going to have a hard time operating your meter without them. What they're really handy for, I found mostly for when you're doing home electrical and you're testing like your three-way switches and your wiring and your hots and your neutrals and all that kind of stuff, it's really great to be able to, clip these on to whatever you're trying to test. So you can clip it onto whatever wires and then, this gets hooked up to your meter and maybe your meter's hanging there, or maybe you have a way to hang it or to latch it onto something with the stand. And then you can walk away, you can go to the breaker box, flip whatever breaker you need to, and then you can walk back and look at your meter and see if it's hot or nothing or whatever. So it's a really handy tool I found for a home electrical, or if you're doing like custom wiring stuff like for automotive. I didn't see batteries in the box, so I don't think it comes with batteries. We get a thank you and a user manual. Very cool. We've got a hold backlight and a select button. Kickstand. Always nice. I'm pretty sure I'll have a link to this meter down in the comments section. I don't know the price of it, but I know it's less than $20. And it comes with batteries installed. Oh my gosh, these guys are killing the meter game. I got to get stock in these guys. Who owns AstroAI? They even carry them at Walmart. That's how much they're killing it. We're going to go over ports. We're going to go over NVC. Is this a True RMS? We'll go over True RMS. We'll go over the counts, what that means. We'll try to do a lot of these details that you might just not know about your meter. And then, obviously we're going to go through every test setting and show you how to do the tests. And it looks like they are both fused ports. And if you want to get to your fuses on a meter like this red portion here is going to be a cover. Yeah, and that'll pop out, and you'll have to do the dance of pulling this cover off to get to those fuses. So try not to blow them. And it is an auto ranging meter, which is really nice. That'll help shorten up this video a little bit. So let's get into True RMS and what that means. I know that you can Google it or ask Gemini or whatever. You're going to see that it stands for root mean squared. And we're just going to draw a couple little graphs really quick. When do we want True RMS? I didn't even know you could get a meter at this price point with True RMS. God, I would love to be a sales guy for them. These meters sell themselves. True RMS, why do we want it? What's it for? So it means root mean square. And why is it important? Well, whenever we have a meter that can make current measurements, which this is capable of doing, which is insane, we got a problem. And that is that meters are really good at static measurements and not fast moving measurements. You know, a meter has typically just one set of numbers to put up on the screen. And so when things move around really quick, the meters have a hard time trying to communicate to you what's going on. So what they had to figure out was like, okay, we need a value to translate AC to DC so that they're equivalent. When you're looking at the amount of DC current or AC current, when you see 10 amps on both settings, they need to be equivalent to each other. And how do you do that with AC? Because AC is constantly moving back and forth from positive to negative. And so depending on where you take your measurement in time is going to change the value that you get. So if I took a measurement here at the peak, this would be my peak voltage, it would be like negative 144 volts AC. But then if I took my measurement here, it would be 0 volts AC. And then if I took it, you know, maybe here, right? You see what I'm getting at? Root mean square is really handy because think of it as like the average reading of AC voltage or current that will give us a DC voltage or current equivalent reading. So like when we take an AC voltage reading of an outlet, and for where I'm at here in the US, that's 120 volts. The peak voltage of this outlet is closer to something like 144 volts. It's not 120. The 120 is the RMS value. So to have true RMS means that we're getting accurate AC voltage and current measurements. And it's something that's going to be really important if you plan on doing AC voltage and current measurements. Okay, so that's something that we have there for true RMS. Whenever you see that listed, it automatically makes that tester or reader or whatever more valuable. Like I have this K-Wheats socket tester. K-Wheats is an affiliate. I do love them as a company as well. This outlet tester voltage though is not very accurate because it's not rated for true RMS. When I take a measurement of an outlet, it always shows, let's just see if we can do a quick example. It always shows a few volts less than what's actually present. And we can even, let's just take this bad boy for a little spin real quick and see what the measurement compares to. We're gonna go over ports here in a minute. Compares to a true RMS meter. I've been trying to get in a better habit of wearing my electrically insulated gloves for these videos. I've got a new pair that's coming. If I like them, I'll put them down below. But we are on the volts AC. See how it's 120 right on the money? And this one says 117 to 118. That's the difference that you get when you have something rated for true RMS. You don't even want to know how long it took me scratching my head at night to figure out the difference in those readings. But once I figured it out, I was like, we got to put that in a video. Let's go over 4,000 counts because that's going to be a really popular thing that you see advertised, at least with the meters online, they really like to push their count number, whether it's 4,000 or 2,000. The big box store meters, I don't really ever see them advertise their count value. At least that I've noticed. I could be totally wrong. But what is your count value and why is it important? So we've got this decimal point on here, right? And we've got a bunch of different things that we can measure. And things that we're going to want to pay attention to on this screen are going to be that decimal. And then it's going to be like units of value. So we want to look for things like capital M, K, lowercase m. I think there's nano on here, micro, things like that, and then that decimal. And that's how it's going to communicate to you a very large variety of values, because I don't know what the limits are on this without looking at the manual. But let's say this thing is capable of measuring up to, let's say 20 million ohms. And then it can tell you a number as little as, let's say, 137 millivolts or something like that. That's a huge span of numbers to communicate over. You can see on this display, there's 4 positions on the meter, right, for the meter to communicate. It's going to use that decimal, and then it's going to use these little guys right here, your different units. So let's say I'm measuring 120 volts. We got that to the tenths place. So we have our 4 slots here. I'm doing 120 volts, but then to the tenths, then we have 4 slots. And then we can have, let's say we're reading 137 millivolts. It's going to be something like that. So, and usually there's, on an auto ranging meter like this, there'll be like a slide indicator down at the bottom, and that'll let you know where you're at in your range before it has to select over to the next unit of measurement like it does down here. It doesn't appear that it does on this one, but that's also another thing to kind of be mindful of when you're looking at meters. For an auto ranging meter, it's not really that important to know your range count, whereas on a manually selecting meter, it's something that you want to be a lot more in tune with. That's what they're saying when they're advertising 4,000 counts. We did True RMS. Yeah, and you can see on the box here, it says max display 399. So that's tied into that count number that we were talking about. Resistance. It can read up to 40 mega ohms. And then you can see this is the range values that it's going to cycle through. That's cool that they have that listed. I don't know how well that comes up on camera, but your first range is 400 ohms, then it's 4K ohms, 40K, 400K, 4 mega, and then it gives you accuracies within a certain percentage. That's really great. We need to go over the ports and we need to go over these buttons. If you hold down this button, that'll be your backlight. Okay, we're in the volts. So select is to select between, like you're gonna notice on here, but when you see a solid line and a squiggly line, the solid line represents DC and the squiggly line represents a sine wave for AC, kind of like the little graphs that I had on here before. So whenever you see a solid and squiggly line together, it's saying, look, this setting is rated to measure both DC and AC with this measurement. Like all these guys over here, this is for microamps, milliamps, and amps. It's also indicating that it can do that for DC and AC for all 3 of those settings, which is really cool. And then for this portion here, this is diode continuity in ohms. And if we go to that little guy, it's going to default to ohms. I wish it would default to continuity, but we can go through the selector switch. It goes to diode, and then it goes to continuity. And then if I just do a quick press of that button, a little H comes up, and it's telling us, hey, we're holding that value for you so you don't have to keep your leads on that power source. And you can write this down or take note of it or do whatever, walk away, and you have it temporarily stored until you just do a hit of that button again, and then it disappears for you. AC and DC voltage measurements are really straightforward. You're just going to make measurements in parallel with your circuit. Your circuit doesn't have to be loaded. It can be loaded. Voltage just has to be present. And you just make a measurement in parallel, just like that, just across your terminals, across your red and black or your hot and your neutral. You know, so that's an example with the little light bulb circuit, with your battery. Your battery voltage is present, but there's no circuit loaded up on it. And again, we can just take a voltage measurement. So pretty straightforward. And that kind of lends to our ports. What are they for? And that's where the labeling down here is going to get kind of important, because you're not very well set up for success in knowing when to use which port, and it's a question I get asked about all the time on here. The COM port stands for common, and that's for your black lead. It will go in there and live in there for the rest of the time. You'll never have to worry about moving the black lead. You may be asking, well, if it's supposed to live there always, why can you even pull it out in the first place? That's because your meter leads are a wearable item. They're like the guitar strings of your meter. They're going to wear out eventually over time. They'll get moved and flexed around. The wires will start to degrade over time. The ends, these pointy ends that are nice and stabby, they'll get dull. You'll do shorts. I mean, you're going to beat up your leads. They're meant to be replaceable, but your black lead will always live in the common port. Your red lead is what's going to switch around every once in a while, depending on the type of measurement that you're doing. And this is where things can get a little confusing, so just bear with me. And this is where these labels down here are going to come into play. So we can see here, fused for up to 500 milliamps. Anything after that, you're looking at being barbecued or blowing that fuse in there. And then this port fused for 10 amps. We're going to use this port 99% of the time. This is going to be for almost every single measurement that you do, except in the case where you're going to measure current that's greater than 500 milliamps, but less than 10 amps. And I know that's a little confusing. You'll get the hang of it. Trust me, just bear with me. Very specific circumstances, you're going to use this port. It's going to have a different size fuse. It's going to be set up way differently than the way that the internals of the meter are set up for this port. But most of the time, a lot of the times, you're going to be using your meter for continuity and voltage checks. And this one can do some battery testing for you, which is nice. And we're just going to go through the dial clockwise. So our next up is going to be, it's going to default to resistance. Let's try to get this glare out of here. It's going to default to resistance values, which again, I would have liked it to default to continuity because that's what you're going to be using it the most for. Now, I want to stress that resistive measurements are not just for resistors, although I use them for examples. You can use resistive measurements for a lot of different types of troubleshooting. I like to use them a lot for seeing if there's opens within an electrical circuit. So like with this light bulb, let the meter chooch, it's saying, okay, we've got to pay attention to that decimal. It's saying there's about half an ohm of resistance, okay? So that tells me that there's integrity, some type of integrity in the circuit. It's not a guarantee that the circuit is good, but it means that there's low resistance going through here. If this number came back and was like 10 million, then it'd be like, okay, well, electricity is going to have a really hard time trying to get through this thing if there's 10 million ohms worth of resistance, right? So it's a really low amount. So that's saying, okay, there's a good chance that electricity is going to have a pretty good, easy time trying to work its way through here. You can even use it for checking motors, if a motor has an open or not. And again, these are going to have really low resistance values, 1.5 ohms. Not a big deal, but it tells me that there's some type of continuity in there. It's not a completely open circuit if I'm trying to troubleshoot something like that. But we can just go over really quick. I've got a few different resistors we can just check the values of. Okay, so this says 98.6 K ohm. You got to pay attention to our units down here, K ohm. So how many ohms is that really? Well, K, we got to think 1,000. For kilo, I always think a kilo. Since there's a K down here, we're going to take that K and times it by our shown value. So that means there's 98,600 ohms worth of resistance. There's no way to manually cycle through the different ranges. Oftentimes there can be for an auto ranging meter like this, but there isn't on this one, so don't even have to worry about it. Let's try another value. Remember, we can go up to 40 mega ohms. Okay, so here's one. We got to pay attention to that capital M, mega, think of millions. What this is really saying, it's not saying 1.049 ohms, it's saying this is 1,049,000 ohms of resistance. And then we can go to something a bit smaller. There's a little bit of delay because it's processing. It's having a process doing that auto ranging. The manual ranging ones will be really snappy because they don't have to think at all. You do all the thinking for them. This one has a little brain in it. And it's telling you 68.8. There's no unit of measurement down here. So just 68.8 ohms of resistance. Let's cycle through to the next. We have diodes. Diodes, we can just do a really basic, it's just nothing fancy, not like a Zener diode or anything. The way I always like to remember doing diodes is there's an arrow with a line through it, and that's telling me chooch in that way. And so I like to line up my line on my diode with the line of that. And if I want to make a check, we're going to check it in both ways, but the first thing that we're going to check is this way. Use that hold button. That's telling me in that direction, there's 0.548 volts of voltage drop across my diode. Or another way that we can think of this value that might be easier once you start to pick up on this stuff is the way that I see this value in my head right away is 548 millivolts of voltage drop. And generally speaking, we want to see between 500 and 800 millivolts of voltage drop across our diode in one direction. And then we want to see that OL still be there when we test it. See the lines on the other side this time in that direction. And that's telling me that there's no backflow and that this diode is testing good. And that brings me to what the OL means. It can change depending on the context of your testing. In this case, it means open loop. So it means that, because electricity likes to be in a circle, and when the loop is open, no chooch, right? So open loop means you're out of dice. It can also mean out of limits, depending on the context of the measurement that you're trying to make. So just keep that in mind. And continuity. Continuity, what is it good for? It's going to emit a little tone. It's a good way to check the integrity of your leads. If that tone is dropping out when you're moving your leads around, it's not always a good indication. They're really good for discerning who's who. Now, this is a really small example. Usually when you're using continuity, you're facing up, 3, 4, 10, 20, 40 wires, whatever, and you're trying to figure out who belongs to who. And so what we can use this tone for is, say I'm in a situation, I want to know which terminal the red wire goes to. Well, I can do a quick check. I can put one lead on my red wire. Okay, I get no tone there, but I get a tone there. The tone is really helpful because then you can keep your eyes on what you're putting your probe on and you're just listening for it. And you don't have to focus your eyes on here and then look back here and then lose your place here. And then we can do, the same for this little black lead. Okay, and it's telling me it goes there, and then it's showing our resistive value on the screen, saying there's incredibly low amount of resistance. Capacitance testing. Someone came to me and was like, look, no one's testing these types of capacitors. And that may be true, but you know what? This is a hobbyist meter. You could be testing this type of capacitor with it. We're going to go over the type of capacitor you have in your AC unit for your house, because I think that's what a lot of people have been requesting. This is just your run-of-the-mill capacitor. It's rated for 680 microfarads. The limitations of this are going to be, I'm sure it's in the user manual, but it's not on the back of the box. So let's see if it can, you always want to make sure that your cap is discharged, right? Because it can back into the meter and damage it. And there is a negative sign on that, and that's where you're supposed to put your negative lead. Give it a minute to charge up the capacitor, and then it's going to come back 630. This is a very, I know it looks very large and intimidating. This is not a start capacitor, it's a run capacitor. So the actual capacitance level of it is incredibly tiny. Magnitude smaller, the amount of capacitance, than this one. It's so large because it's rated for an insane amount more voltage. This is only rated for 16 volts, and this is rated for 440 volts AC. In here, there's two separate capacitors. Okay, that's what they're trying to say here. There's a 35 microfarad capacitor, and there's a 5 microfarad capacitor, and both of them are rated to be within plus or minus 6% of that value. And then on the top, we have Herm, Fan, and C. C is for common, not for cookie in this instance, okay? Our common lead can go to the C terminal. You know, you always, best practice, make sure that your capacitor is discharged. I am in a bad habit. I just like to short them out with a screwdriver or whatever. I think by the book, I think Fluke recommends a 10K ohm resistor across, you know, your capacitor leads to discharge it. And you're discharging it for your safety and also for your meter, you know, so it is an important step. But Herm is for hermetically sealed. I think it's the dumbest label that you could put on a capacitor. Who cares if something, I don't know. I don't make them, I just test them. All right, so we've got our black lead to our common and our red lead to our Herm terminal. And we want to give it a second to charge up. And we're coming back with 34.79 microfarads. That's what that funky little U is on there. We can do from our common terminal to our fan, and we get that 4.98 microfarad, and it's well within 6%. So that's how you would test like your AC run capacitor with the capacitance setting on here. Next up, we have the battery testing settings, and these always cause a lot of havoc in the comment section. People get very heated about this. These battery testing settings are for small batteries. That's it. And they're supposed to be the equivalent of replacing something like this. Now I got this in my battery daddy. You know what I'm saying? Your 1.5 would be good for a little battery like this. And it's going to put a little load test on it. Okay, it's going to drop down the internal impedance of the meter, and it's going to load this little guy up, and we're going to get a value. And then we can do it for 9 volts. I had one guy in the comment section the other day for that setting. He's like, why would you even bring up car batteries with the 12 volt setting? Or I don't know. He lost his ever living mind. A lot of people think that the 12 volt battery test setting on here is for testing a 12 volt car battery. You have every reason to think that. That makes total sense. Myself included, I would think that. That's not what it's for. It can't load test a car battery. There are tests that you can do with the car battery with the multimeter, but this is just doing a little bit of a voltage check. That's the biggest check that you can do this way. The other tests to check car batteries with multimeters are a lot more involved. They're beyond the scope of this video. When you're testing large batteries, you need mass. You need like actual large material to stress the battery and check its voltage drop. And something this small is just not capable of doing that. It's just the physics. They don't add up. You know what I mean? All right, next up we have the really exciting stuff. And this is where we're going to start to kind of want to think about our ports and how to reason when to swap over to the other port. And that's because we're getting into our current measurement settings. This is rated to do microamp DC and AC, milliamp DC and AC, and just whole number amperage DC and AC. Okay, that's what these 3 yellow settings are for. My rule of thumb, whenever I'm doing testing where I can manually select through these different ranges like that, we got to think, why are we doing testing in the first place? We're doing testing in the first place because we do not know the voltage, resistance, or current of whatever part of the circuit that we're trying to troubleshoot. And that's why we have the meter out in the first place. We're there to do checks, confirmation, and discrepancies. Because we're working with unknown values, I always start with the biggest. And so when I start with the biggest, I'm going to move my red lead over to this port. Make sure that if you're doing an AC current measurement, this defaults to DC, and that's going to bite you. So I'm making a DC current measurement. I have it selected to DC, but if you're getting funky values and you're trying to measure AC current, that's probably what's biting you in the butt, is you forgot to swap it over. I've done it a million times on this channel. Thank God for editing. You know what I mean? I've got it on DC amperage. I'm on the biggest amperage setting, and I have my red lead over here. I'm about to measure some DC current in series with my circuit, right? As opposed to parallel. Parallel, I could just throw my leads on to here, right here. In this configuration, it is so important to note, and this is where things get really hairy for a lot of people and mistakes get made, things get shorted out, tears are shed. In this configuration, your multimeter is essentially a jumper wire, okay? There's like no resistance between these two terminals. Your meter leads right now, the difference between your meter leads and this piece of wire in this configuration is that this can shoot out a measurement and this can't. That's the only difference. It might as well be a solid wire. So if you took a solid wire like this and you started, poking around in things that are live, you're going to start shorting things out. So you got to be cognizant and aware. I'm going to make my measurement in series, and let's see how it goes. Okay. So 2 amps DC current measurement is just what I took. This is when we want to start thinking about, okay, I'm rated for up to 10 amps in 15-second max intervals in this port. I just measured 2 amps of current. I'm well within my max current rating for this port. If I tried to take this measurement with this lead in this port's only rated for 500 milliamps. So what's that in relation to this number? Well, think of 500 milliamps as 0.5 amps. That would be the most current that we could run through here without risking blowing a fuse. So we're at 4 times that value. So that's why we always start big, because you have no idea how much current is being drawn. Especially too, if there's inrush current that can blow a fuse that you didn't see pop up on your little screen here. Let's take another current measurement with a different example. I'm keeping in mind that this is a DC motor. I have DC power supply for it. We can take a current measurement and see where it's at. Okay, so now I'm at 427 milliamps of current, and that's under the 500 milliamp max fused. Something nice about doing current measurements for motors is if you have known values, let's say I took a current measurement of this and it was reading, 0.7, then I would know, okay, there's some kind of load being placed on the motor and it's having to draw more current. That's just a troubleshooting tip for little motors for you. We're within the range of this one, but something that we even want to consider too is our inrush current. And what does that mean? And how can we think of that when we're trying to make measurements and we're trying not to blow fuses in meters? Now it's rated for AC and DC, so we'll want to think about it for both. When we turn on an electrical load, our current is going to spike initially. All we need to know though when we're making measurements with our meter is that we have to mentally build a model and keep in mind that there's going to be an inrush of current that's going to flow through our meter. And with DC and AC, this is kind of what it's going to look like. The measurement that we end up capturing is going to be down here. You know, this is within like the first 100 milliseconds or something like that, you know, depending on the load of the measurement. By the time that we process it and are looking at it and press the hold button and all that stuff, we're going to be way down here. So we're going to be looking at the but what we're capturing with our meter is going to be on this side. There's going to be that giant inrush. Now, this giant inrush may or may not be strong enough to blow the fuse in your meter. Something to keep in mind when you are doing current measurements with DC or AC, you're going to see a much higher number, possibly, briefly, and then you're going to see your static measurement come into play. So just something to think about. With current measurements, we start big, we get an idea of what's going on there. Yeah, this is only 400 milliamps of current, but that inrush, you know, could be somewhere between 4 and 8 times your static measurement. Let's get into some really small measurements, because I always think that's the most exciting part of this, because I'm a silly goose. I know it's a really funky setup. It's really handy for instructing with the manual ranging meters, but it's really handy when we start getting into this really small stuff. I'm going to stay in my current configuration, but these are all going to be rated for much smaller amounts of current. Let's take a look at what we get. This would be 36 milliamps. This port is rated for up to 500 milliamps. This is well below what this port is rated for. I feel confident that we can move our lead over. Can move our lead over, and then we can go down. Now we got to pay attention. Now we're in the milliamps. Our values are going to be displayed in milliamps. So we got to be cognizant of that. Instead of seeing 0.036, what can we anticipate seeing now? 36. And now we can read it to the hundreds, which is insane. This meter was like $18. Okay, so we can keep going. What's the next spot down? Okay, 12 milliamps, getting small. Okay, 1.17. Another way that we can look at this is this would be 1,180 microamps. That's that funky looking U there. That's the next slot down. And now you can see, okay, 0.11 milliamps, that's 110 microamps. Now I think we can go ahead, go down to the next one, and now we can look at all that detail. 121.2 microamps. That's an insanely small measurement. I mean, it's like we don't even really ever take the time on the channel to think about this. If we just kind of look at this in placeholder value, this light bulb was at 2 amps. The measurement that we just took is all the way down here. That is insane and very incredible, and just such a powerful part of all of this is how small that number is. Non-contact voltage. Some of these, probably not this one. Yeah, it does. Okay. This is a cool trick. I don't know if they'll teach you this in school. For the non-contact voltage setting on these, a lot of them have what's called a live setting that they've been trying out on a lot of these from like AstroAI, K-Weets, a bunch of the ones from off of Amazon. And you don't need to use the antenna in the meter to pick up on the voltage like you do here. See how it's picking that up? And it's not doing a great job of it because it's a huge blocky thing. You can just use the red lead. Let's bring this into frame. And you can hear that thing going off like an animal. You could just use the red lead to probe things. Saying, oh, something's there. Not really sure. Something's definitely there. Not terribly accurate, but yeah, super cool. Anyways, folks, if you're learning this stuff, I've got a bunch of shorts and long form videos and like every different meter that you can think of, where I go through and explain all the different settings. So go check it out. I've got a ton more. Got any questions, comments, or concerns? Let me know down in the comment section, and I'll catch you on the next one.